So what I was hoping to talk with you about a little bit this afternoon is thinking about some ethical challenges in the world of technology, some of the things that we're immersed in. But to kind of think about some of these issues, just to provide a little bit of context for some of you who've been away from campus for a little bit, computer science is now actually the largest major at Stanford, by far. This past year, we had 400 students in 1 year declare computer science as their major. So if you consider a class at Stanford now is about 1,750 people, that's over 20% of Stanford undergrads are computer science majors. And we're one of over 50 departments on campus. So you can sort of do the math in terms of if we had an even distribution. I also like to put up this graph. This actually comes from The Atlantic because it has Stanford as the highest one above Harvard and Princeton and Yale and everything else. But it gives you a sense that this is not just the Stanford phenomenon, it's not just the Silicon Valley phenomena, but is actually a national phenomena that's played out over the years, and these numbers continue to go up. So along with that backdrop, there's lots of interesting technological innovations that have come out of this place. One of them that you've probably heard a lot about, or maybe actually have been in yourself, is an autonomous vehicle. This is an autonomous vehicle that was called Junior. It was actually part of something called the DARPA Urban Grand Challenge. And really the way we think about it is a robot on wheels, and the wheels just happen to be a car, so you can also put people in that robot and it can travel around. And one of the things that was interesting at the time was Sebastian Thrun, who's the faculty member who led this project. This was back in 2011, so just a little over a decade ago, made what was considered a very bold claim at the time, which was that in 50 to 60 years from now, cars will drive themselves. And it was a bold claim because many people actually heard that in the research community and thought that that was far too aggressive prediction as to when we would get autonomous vehicles. Well, it turns out, in fact, that was not aggressive enough, as you all know, because if we fast forward a little bit, it turns out Nevada became the first state to actually issue an autonomous license for a driverless car. You have to change regulation to go along with technology. Anyone here from Nevada, by the way? A few folks? Yeah, just be careful when you're out there. It turns out California also has licenses now for autonomous vehicles, as do many other states. And so it brings up kind of interesting questions when this technology gets developed. Here is a self-driving car. I actually took this picture myself out of the passenger side of the car. I was not driving in 2015. So just 4 years later from Sebastian's original statement about self-driving cars, they were already sort of on the road. And now there's many companies that are developing this technology. There's actually autonomous taxi services operating in certain locales. So the technology is moving quickly, and that's just as a backdrop to say sometimes the technology moves so quickly it is difficult for us to keep up in thinking about what are some of the ethical challenges and what are some of the regulatory responses to the development of that technology. And so one of the things that comes up in the realm of autonomous vehicles is why do we think about having them? One of Sebastian's actual motivations for autonomous vehicle is one of his best friends died as a teenager in a car accident. And he said, maybe we can make driving safer for everyone. And if you actually look at driving, it is a huge cause of fatalities, about 30,000 fatalities in the United States every year, actually a little bit more than that. And so it's estimated that potentially autonomous vehicles could have the potential to save 300,000 lives per decade in the United States alone. So there are some real pluses, there are some real advantages to thinking about what this technology has to offer, but it also brings up some questions for us. And one of the things to actually think about is that as human beings, we're not very good drivers. So the National Highway Traffic Safety Administration, if you follow that kind of thing, estimates that 94% of auto accidents are caused by human error. And so I saw that and I thought, wow, that's a big number. And I thought, what else causes auto accidents? And it turns out the other 6% are things like mechanical failures. Right, so we are not particularly good drivers, as it turns out, but that doesn't stop us from driving. So when we think about these kinds of things, it begins to bring up some moral challenges for us. What are some of the questions? And so I'm going to start with something that's actually a moral question that many of you have probably heard before, just to kind of set the stage before we go off into other directions, which is to think about what should an autonomous vehicle be programmed to do. And we could think of, there's a bunch of different possibilities, but two big ones. You could say it should aim to maximize driver welfare or global welfare. We could think about if the car is considering a situation in which it's going to be involved in an accident, what should it do in terms of maximizing human life overall, or just the human life of the people who are actually in the vehicle. And so what moral code, in some sense, should it be confronted with, right? That's something we have to decide as human beings and encode in the programs or systems that actually get built into these things. And this is an instance of the trolley problem. And when autonomous vehicles came out, philosophers everywhere rejoiced because it gave them an opportunity to bring up this 50-year-old problem from philosophy in the context of autonomous vehicles. And the way this problem basically looks like is, imagine you have an autonomous vehicle going down the road and it loses control. Like there's some mechanical failure, brakes fail. And there's two things that can happen. There happen to be 5 people crossing the road, all bunched together with skulls and crossbones over their head, which is why this is a philosophical problem. Car can either go straight through and potentially kill those 5 people, but save the passenger in the car. Or the car, realizing that the alternative would be to kill 5 people, could say, what I'm just going to do is just swerve off the road, killing the passenger in the car, but then I don't run over the 5 people. So what should it do? I can pose that question to you. How many people think it should kill the 5 people crossing the road? We got a couple, all right. How many people think it should just swerve and kill the driver but save the 5 people? Interesting. That's actually what most research says should happen. So one of the things that is interesting about this is let's see what people want and what they say they want and how that actually translates into what would be built. So Bonifant and colleagues back in 2016 did this interesting study where they went and asked people basically this question. They said, should the autonomous vehicle, that's what AV is here, take a utilitarian stance? Should it try to maximize human life? And so on this scale, basically, 100 is minimize casualties on the road, 0 is protect the driver. And so you can see the vast majority of people are over at 100. Say, yeah, we want to minimize the loss of life. That's what these cars should be programmed to do. That's interesting. But then when they asked the individual, what do you want in the car you buy? The person said, I would prefer to ride in the AVs that protect our passengers at all costs. And as a matter of fact, participants disapprove of enforcing utilitarian regulations and would be less willing to buy an autonomous vehicle that was maximizing overall life. So this, I'm not an economist and I don't play one on TV, but at least sometimes I can look at things like this and from an economic standpoint say this is what we would refer to as a market breakdown. Right, there's something we would want as a society, which is to maximize human life in the programming of these autonomous vehicles. But what the market would give us based on consumer demand is to actually program the EVs just to protect the driver of the vehicle. So there's an outcome that we want. There's an outcome that we would get just by market forces. Those two things are different. So how do we think about these kinds of things? And what it leads us to realize is that in technology, there's lots of places where choices are made to maximize particular things that a small group of people want. And what happens as a result is it sacrifices, in a larger social condition, what we might actually think is the thing that we would want to maximize societal benefit. Okay, so what does that look like? Well, what that looks like at Stanford and in Silicon Valley is there was a big shift over the last 10 years from this notion of tech optimism, right? We're going to make the world a better place, to a notion of tech pessimism, which is maybe we're going to change the world, but not so much. So when I was walking in here, actually, there was a banner at the business school that says, change the world. And the thing that came to mind immediately is it says change the world, but it doesn't say for the good, right? And so that's one of the things, I always kind of keep in mind is when we want to make those changes, what are the impacts we're actually having on the world? And there's lots of negative externalities, and to use the language of economists again with respect to technology, places where what happens with a negative externality, right, much like pollution, is that there is some benefit that is, say, going to the corporation that is polluting, and then society has to deal with the consequences, which is the pollution, right? That is the negative externality. So what does that look like in the tech world? Well, in the tech world, collaborated with 2 other people, because one of the things we're realizing in doing this work is no one has all the answers, and that is an important thing, is to be humble in trying to approach these kind of problems. So I've been collaborating the past couple of years with Rob Reich, who's actually a moral philosopher, and Jeremy Weinstein, who's a public policy person. We created this little class together, and everyone got to choose basically one phrase in the name of the class. So you have the ethics person, the public policy person, the technological person. It's cross-listed in a bunch of departments, but it's the point of doing this class, and we did a little book too, is really to think about what are the larger issues that we need to deal with and how do we deal with them in different ways. And when we try to unpack the problems, one of the things you see sometimes in congressional hearings or when you read the news is it's all written from the standpoint of good and bad people. And it's let's take, someone like Mark Zuckerberg or Sundar Pichai and bring them before Congress and ask them a bunch of questions that actually reveal how much people in Congress don't know about technology. which is sometimes embarrassing. They're getting much better, I would have to say, to be honest. Actually, they're sort of upping their game, and that's something we'd like to see in the future. But the real issue when we try to unpack it, at least from our standpoint, is it's not about individuals. It is about systematic drivers. And if we can understand those systematic drivers, it lets us understand a little bit more what are the systematic ways we can address the issues. So what are these systematic drivers? How do these externalities get generated? One of them is we think about the notion of optimization. And if you come from the engineering side of the world, you're probably familiar with that concept. There is something we care about making some quantity, either making it larger or smaller. We want to optimize something. And so it's a particular mindset we get into, and that mindset applies to a bunch of things that are not just numerical problems, right? But like life hacks. I'm doing this thing to save some time, or I'm going to drink Soylent now because that's the thing that makes my nutritional consumption faster. I don't know if anyone drinks Soylent in here. Anyone do? Yeah, a couple. Yeah, every once in a while. Thanks for admitting it. We'll talk later. Yeah, but that's the idea, is we're trying to optimize things. And so what does that mean in the context of technology? What it means is we can have some high-level goal we want to achieve, like, say, Facebook. Their stated mission is to connect the world. Well, what does it mean to connect the world? Right? How do you measure that? So if you want to try to optimize it, the way you measure it is you look at things like how much time do people spend on the platform, how many pieces of content they click on, how do they engage with those pieces of content? And you realize that these things are all proxies for what we actually care about, which is connecting the world. And sometimes when you have bad proxies and you optimize them, you get to outcomes you don't really want. Because it turns out if people click more on things that are inflammatory or polarizing, that increases your click-through rate, but you're not really connecting the world. And so that's part of the issue that's going on, is we have these poor proxies for the things that are actually being optimized, and then there's an obsession with scale. And I say this as a computer scientist. One of the things we really care about is how do you scale everything? You try to make it as big, as fast as possible. You also have funders, say venture capitalists, who want to see hockey stick growth in the growth of their companies. And so what they do is they're pushing people to look at these metrics and say, how do we make them bigger faster? Because that's how we maximize our returns. And so there's a whole ecosystem around measurement and maximization and trying to do that as quickly as possible. And at the same time, we get this deliberate indifference from politicians that creates basically an open ground to do whatever you want. And the interesting thing from a policy standpoint, so I'm not a policy person, but working with two people who come from the political science department, you spend a lot of time, it was like being a student again. It was like, here, go read this, go read this, go read this. And I was like, I'm like 45. This was 6 years ago. And I feel like a freshman again, because maybe I should have taken like Poli-Sci 1 and Philosophy 1, and I didn't, and they were actually pretty useful things. But one of the things you realize is back in the 90s, mid-90s, remember Al Gore invented the internet? You remember that? So what was it that was actually the reason why Al Gore invented the internet? The reason was there was a bunch of regulations around the use of the internet, like regulations around commercial activity, for example, that was prohibited. Those regulations got pulled back in an attempt to try to have the internet itself be a fertile ground for innovation. And that regulation actually, I think, worked well. There's something called the Communications Decency Act, which you've probably heard about in the news now, in a particular section of it, Section 230, that gave companies basically immunity from a lot of liability for the information that's on their platforms. But it allowed for a flowering of the internet. The problem is now we're almost 30 years later, and we're in the same regulatory regime we were 30 years ago, and a lot of stuff's changed in technology. So let's dive into some of those things to understand kind of how we think about some of the different issues that come up. Big one is around algorithmic bias and fairness. What do I mean by this, right? The idea is that there's a lot of algorithms now, computer programs basically, that are making decisions about important factors in our life. Okay? And so these are actually used widely across some of the most important sort of transactions that happen in our life, or interactions. Who gets credit, who gets selected for jobs or for interviews, who gets access to healthcare and what kind, who gets bail in the criminal justice system. I won't even talk about dating apps. We can talk about that afterwards. That's kind of a two-beer conversation. Okay? But lots of questions about our life that are now being decided by algorithms. And so there's a promise here, and the promise is, can we improve accuracy or efficiency of these algorithms? Because it turns out we're also pretty bad at some of these decision-making processes as humans, right? Can we diminish or eliminate bias? Can we try to eliminate some level of randomness because we have these algorithms making more consistent decisions? Can we get around human fallibility? And those things are all nice goals to have, but there's also perils. Are there biases that these algorithms are encoding that now get more widespread because they're used at scale? Does it threaten fairness? Do we actually have privacy or transparency or due process? Right? When a human being makes a decision, you want to challenge it. You can do that and have that process revisited. What happens when an algorithm makes a decision and you say, I don't agree? They say, well, let's run the algorithm again. Hey, guess what? Same decision. Okay? So what does that mean for us in sort of a broader sense? And so the way I like to think about it is algorithms are a mirror of us. And what they do is sometimes that mirror doesn't look very nice because what happens is it forces us to make realizations about what values are important to us and what decisions we want to make that we were never confronted with before. And the reason why is because we're confronted with them now is because if we want to encode decision-making into an algorithm, we need to be extremely explicit and precise about what are the values we care about. If we're going to build a car to decide, does it kill 5 people or 1 person, you have to make that decision a priori and put it in the code, which forces you to make that decision. And so this is what's happening now in a bunch of different aspects of life. We need to figure out for ourselves what are the things we care about and what are the decisions we want to make before we actually put it in an algorithm. Now, this brings up a traditional or a natural question sort of in the field. What is fair? Right? And it's one of those things you're like, well, it's kind of like pornography. I know it when I see it, right? But what really is fair? Right? If I have a school system and it gets a certain amount of money from the superintendent, what is a fair allocation of that money? Do I fund every student equally? Do I have some students that have particular needs and so I need to buy assistive technology for them? Well, that's not an even distribution of money, but I might say that creates more fairness or justice. And so these are the kinds of things we need to grapple with. And the problem is when you need to make that decision, some algorithm needs to optimize something, you got to tell it, this is the thing I care about. And if this is the thing I care about and this is the thing I'm going to optimize, that means it is supreme over all the other decisions that could have been made. And that puts us in a situation where we need to be explicit about it. And you also need transparency. People need to understand when algorithms are actually being applied to them. Most people don't these days. What data is the input? What's the context? Do I get all the other things I sort of believe in the legal process with due process? Is it accountable? Can it be challenged? So let me give you a particular example. And this particular example is thinking about how fair are we to begin with. So this was a study that was done about 10 years ago where they looked at judicial decision-making by human judges. And they said, based on the time of the day, so this is one day, what is the likelihood of a favorable outcome from the judge to the defendant? Okay? Now, since that time, in the last 10 years, to be totally clear, there's been other research that has actually mitigated some of these results and said it's not as extreme as this original study. So take this with a grain of salt. But this is one day. And so if you look at what happens in the morning, judge is happy. They're hopefully well-rested or whatever. They're getting more favorable decisions. And then they go down. Guess what that first vertical line is? Lunchtime. Right? So they're kind of grumpy. They're hungry. More people are going to jail. Then they have lunch. They're happy again. And then more people go to jail until you know what that second line is? Afternoon break for snack. Yeah, so basically, it's like, you're like, that's like my children. Like, they get a snack and they're happier and they treat me better. Yeah, that's the criminal justice system. Okay? And so you look at that and you're like, maybe we could do a little better, right? Maybe algorithms can actually be applied here. And so, again, it's a mirror to us to actually say what works. So there's an algorithm called COMPAS. This is one of those things that if you ever talk about ethics and fairness, you have to mention this algorithm because everyone in the academic community talks about it. It's a black box model. We don't know what it's inside because it's a proprietary algorithm made by a company called Northpoint, and it's basically used to predict risk of recidivism. If you learn nothing else from this talk, it's a recidivism is a word that means someone's basically committing another crime in the future. Will they commit another crime is the recidivating is the notion. And so this is assessing their risk of doing that for people who are in the criminal justice system, whether or not they should be granted bail while they're pending trial. Okay? And so it predicts a risk score. And the interesting thing about this risk score is that race is actually explicitly not one of the input features to the model. So the model does not know the defendant's race when it's actually making this decision. So I don't mean to traumatize you. I know this is classes without quizzes, but it is not classes without contingency tables. So you're getting a contingency table. And we can look at how this algorithm actually does. So we can look at, did the algorithm label someone as high risk or low risk versus did they actually recidivate or not? Right? So we can actually look at some people over time, see what the algorithm would have said. If they were let out, did they actually commit another crime or not? And see how well the algorithm would have predicted. And so ProPublica is a journalistic outfit that a few years ago did a study of this particular algorithm. And so they said, let's look at how well it correctly predicts recidivism, which is 61%, which is actually not that great for what we refer to as a binary classification problem, which means if you guess randomly, it's 50%, right? There's only two choices. It's 61. So you're like, not that great to begin with. But then they looked at how correct it was for white defendants versus black defendants. You could say 59, 63. Those are both pretty close to each other. Seems like it's a fair, modulo a few percentage points algorithm, until you dig deeper and see how those errors were made. And when you dig deeper, what you find is that of the black defendants who did not recidivate, they had a 45% chance of being labeled high risk, which means they probably would not have gotten bail in the system, even though they were not a risk. For white defendants, that's only 23%. It's half, which means that if you're a white defendant, right, the algorithm does not see race, but if you're a white defendant, you are half as likely to be labeled high risk. Flip side, of the black defendants who did recidivate, 28% were indicated as low risk. For white defendants, 48% were indicated as low risk. So it's almost a factor of 2 to 1 in terms of just based on someone's race, whether or not they would be given bail or not when you dig a little deeper into this algorithm. And so one of the things it brings up is, what do we require now actually about doing this kind of audits to algorithms to understand what they're doing? In most jurisdictions, nothing. Which means you can have an algorithm that's happily making biased decisions based on race, based on gender, based on age, based on a whole bunch of things that we consider what are called protected characteristics. And unless they're audited and examined, which is not required in most cases, they just happily continue to make these decisions. Okay? So how do we think about that? Right? So here come the computer scientists, right? Computer scientists see this problem. They're like, we're optimizers. Let us come to the rescue. So there's a bunch of formal definitions of fairness. I gave you 2 when we talked about sort of the case of schools. Turns out, mathematically, there are over 20 accepted definitions of fairness. And if you're really interested, we can get into the math afterwards. But I'm not going to give you a bunch of equations. Natural question is, can't we just optimize them all? That's what we do. We're computer scientists. And in fact, other computer scientists came along and said, no, you can't. You can actually prove that some of these definitions of fairness, which are definitions people use and care about, are mathematically incompatible with each other. So you raise one metric, you will, by definition, lower another metric. So you have to make choices, right? So this is the place where we as human beings need to figure out what's important to us in what kind of context to make those decisions to encode into these algorithms. And you can get all kinds of complications. I won't get into all the details of the complication, but you can have all kinds of complication, things like protected characteristics, just to let you know, are something that in particular contexts cannot be used to discriminate. So in a job, for example, you cannot discriminate based on things like gender or race or age. In some contexts, those set of characteristics are different. In a medical context, for example, age is something you want to know because, as we're all well aware, we get different kinds of medical care based on the age that we're at and all kinds of tests we might otherwise rather not do. But age is something in certain contexts you take into consideration, in other ones you don't. You can have sets of features that are not officially protected but are highly correlated with protected features. Your zip code, for example, highly correlated with your race for historical reasons. And I don't need to give you a history lesson to understand why, but zip code is something you'd say, oh, that's kind of innocuous. I can have that as a feature in my data. It's an extremely good proxy for race. But I don't have race in my data, right? So in some sense, am I protecting the person? Unclear, because algorithms are very good at finding these subtle patterns. There can also be lots of historical bias in the data, disproportionality. That's what's happened with the data from COMPAS. It was trained on data from Broward County, Florida. And in that data set, there were far more black defendants in the system than there were white defendants in the system. And just mathematically, the way it works out, if you have more data from black defendants, being black means you have a higher chance of being involved in the criminal justice system, according to that data set. Right? So these are the kinds of things we can begin to tease apart, because people look at this and they're like, oh, this is terrible, we should just get rid of algorithms. The one thing I say to them is, you know what? There's human beings that make biased decisions too, and we cannot, under current ethical laws, which I agree with, cut open their head and see what's going on inside their brain. We can do that with an algorithm. So at least it gives us the potential to be able to identify these issues to see if there are ways that we can correct them. We can't always correct them. I'll tell you some stories about that if you're interested later on. But let's move on to another topic, kind of in the broad scope of things. Data maximization and privacy. As you probably know, when you're browsing online, there's a ton of information being collected about you. I shouldn't laugh when I say that, but I kind of do, because I worked at Google for a bunch of years. And there's a ton of data, and there's way more being collected on you now than there used to be. So we can think about why do we care about privacy, right? Famously, a few years ago, Scott McNealy, the CEO of Sun, who was talking more in a governmental context than in a private context, said, like, you don't have any privacy, get over it. And so you might look at that and say, okay, why should I even care about my privacy? And so this is one of the places that, you think about what is the value of privacy, right? This is like the place where, like, I sit with Rob and Jeremy in a dark room and we listen to Pink Floyd and we talk about privacy, man. It's a balance of competing interests. And so what are those competing interests? You could say making data available in certain contexts for meaningful analysis is actually worthwhile. Things like medical analysis. Friends of mine here who work on things like building predictive algorithms to try to predict disease say the biggest thing they run into now is availability of data. It's not better algorithms, it's not more compute. They just need more data, and if they had it, they might be able to do better things of trying to tie particular treatments to outcomes in the medical domain, which would probably benefit a lot of people. But there's lots of regulations that sort of prevent that, at least in medicine. There's also things like you want to be able to audit algorithmic decision-making systems for fairness. Well, you need to get access to data to do that. But there's also the fact that you might want to protect individual privacy. And one of the biggest things, kind of from a philosophical level, is in terms of caring about privacy, is imagine that you had no privacy. Imagine that everything you did, everything you said, every place you went was recorded and publicly available. Would that change your behavior? Would that change what you do? Would that change what you say, where you go, the kind of activities you engage in? If the answer to that question is yes, then you understand the value of privacy for your personal autonomy, for your choices in life. And that's why we think of privacy as being an important and inherently useful value. It's not just because we think privacy is neat, but because privacy is what ensures us to be able to live our lives the way we would like to live our lives. And that's a pretty powerful value. And there's a bunch of things like FERPA, HIPAA. It's so important it doesn't just get three-letter acronyms. It gets like 4- and 5-letter acronyms to protect your privacy. But there are cases where that privacy can easily be violated. So let me give you a simple example. A lot of data sets will have data in sort of a database that people are kept track of as rows of data in a database, and so there might be information in there like the name, social security number. I'm not going to put my real social security number on a slide. Employer, job title, date of birth, zip code, a whole bunch of things. And then say we're in the medical diagnosis domain, we might have something like, does this person have a particular condition or not? Because we want to be able to make some prediction, like are certain jobs correlated with certain conditions or certain locations correlated with certain conditions. And you might look at that and say, well, that's just crazy. Like, I would never make that data publicly available because it's got people's like names and social security numbers in it. I'm like, all right, that's great. Why don't we get rid of that? So we're going to do what's called anonymization. We're going to take some stuff out of the data to see if we can make it available for research or for other purposes where it's anonymous. And you look at that and you say, but Mehran also told me about these things called protected characteristics, and gender and age are actually protected characteristics in a bunch of contexts. So why don't I also get rid of gender and the year of birth? So in some sense, I'm also protecting that attribute from not being in the data. Like, okay, you're dropping a bunch of stuff that might have been useful, but let's just say we want to protect folks. So we can ask how well this does. I don't know, does that look anonymous to you? No. Yeah, so why don't I just take the first line of that database and put it as a query, as just raw text into a search engine and see what comes up. I'm like, I'm number one. Not a great distinction to have when you care about your privacy. Okay? So many of us are just one query away from being de-anonymized. Now, if you think, okay, but this is just one example, whatever, you're talking at Stanford, Mehran, so you can sort of rig this however you want. Let's talk about a real example in the real world, okay? So Massachusetts Group Insurance Commission wants to release anonymized data for employees based on their hospital visits, 135,000 records. Bill Weld, who's the governor at the time, guarantees the public, this has been anonymized. To protect your privacy, we've deleted personal identifiers, all right? In comes LaTanya Sweeney, who at the time was a graduate student at MIT. Now she's a professor at Harvard, and you'll see why. So what does she do? She says, oh, this is interesting. I know Weld lives in Cambridge, Massachusetts. I wonder if I can de-anonymize him. Okay, so what does she do? She goes for $20 and buys a public record, which is the Cambridge voter list, which contains people's names, addresses, including their zip codes, and then things like birth date and gender for about 55,000 people in the county. Okay? She joins that voter data with the GIC data, perfectly de-anonymizing Bill Weld. How does she do that? Turns out only 6 people in Cambridge actually shared Weld's date of birth. Only 3 of those were men, and only 1 lived in his zip code. So, and this is the part of the story I love. To make a point, she mails him his medical records. Okay? Now, you might look at this and say, well, Bill Weld's also a pretty well-known guy. So what Sweeney does is she follows up and she says, you know what? This is true for the vast majority of people in the United States. So, and when I first read this, I was like, really? Like, how can this be the case? And then you do a little bit of simple math called multiplication, and you realize why. So what she does is, her claim is 87% of all Americans could be identified using 3 pieces of information, which generally most people think is fairly anonymous, which is your zip code, your birth date, and your sex. Okay? And so just to do a little bit of combinatorics, there's about 42,000 zip codes in the United States. There's 365 birthdays per year for about 80 years, we'll say average lifespan. If you were born on February 29th, I apologize, we're just going to say 365 days of the year. Most individuals, not all, most individuals, though, identify as one of 2 sexes, so I'm just going to simplify that as a 2. And then you multiply those numbers together. So 42,000 times 365 times 80 times 2 is 2.5 billion combinations. There are only about 330 million people in the United States, which means if you consider all those combinations, most people are singularly identified by that information. And so if this worries you, you can check yourself. There's actually a website you can go to and enter that information and see whether or not you're uniquely identified by those 3 pieces of information. Yeah, feel free to get out your phones and take a picture. Called the Data Privacy Lab, aboutmyinfo.org/identity. And so I did that. I went and put in, I can also share with you my date of birth, male, zip code. And guess what? I am easily identified by my birth date, and there is 1 person in that particular cell that shares those 3 characteristics. Okay? 87% of people get identified this way. And so it brings up questions about what kind of protections we want to have about our data, because it is far easier to be identified in data that we think is anonymous or that other people think is anonymous when they're gathering it than it really is. What are the sorts of regulations we want to put in place? How do we kind of guarantee that privacy so we aren't singularly identified? And part of the larger picture there is who has control over that data, right? So if you think about your location data, right, many of us carry one of these things around, which can know our location all the time. So do we have to rely on sort of the policies of Apple and a few executives there to ensure our privacy as to our location? If that's the case, our democratic process is kind of in trouble. Because what that means is significant decisions about our privacy, and that means about our autonomy, are being made by private corporations that have essentially no public recourse. Okay? So let's talk, and you're like, wow, this one's really uplifting. I'm glad I went to this talk. So let's make it worse. Let's consider autonomous systems, right? So depending on who you talk to, there's a lot of automation coming down the road, right? One estimate, it could eliminate 73 million jobs in the US by 2030. But automation also gives us these other things, right? It can save a bunch of lives on the road. There's actually cancer detection screening mechanisms now, which have been shown in some cases to be better than human radiologists in predicting cancer, right? So how do we think about this automation? Well, it depends who you talk to. If you talk to the fine folks at OECD, they say about 9% of jobs by 2030 will be impacted by automation. If you talk to Frey and Osborne at Oxford, they're like 47% of jobs, which is a pretty significant change. But if you think about that, right, it's kind of like you see the train coming down the track, and you're standing on the track, right? But that train's like 8 years away. It's a pretty long track, okay? Or it's just moving really slowly. What do you do, right? So these are the things that, it's not like these things are like unknowable or they're surprises to us. There are things that we can see now that are coming down the track, which behooves us to think about how do we address these issues. How do we think about social policy? How do we think about job reskilling and training programs? How do we invest in those things well in advance so that we avoid a train wreck of 47% of people becoming unemployed or underemployed, which would be a disaster socially, right? Even a 9% increase triples the unemployment rate in the United States, okay? So these are things we can see now, but knowing this, we have to think about how do we plan for the future. Let's get into the one everyone wants to talk about. I'm on social media, Mehran. It makes me angry. Like, all right, you can get off social media. That is not actually the solution. Why is that not the solution? Because you are not inoculated to the effects of democracy on democracy by Facebook simply because you're not on Facebook, okay? So that's the big question, right? What tech companies will sort of characterize this as is this is your personal choice. This is your freedom. You don't like it, stop using the app. And the problem is that individual choice is insufficient to stop the overall societal effects that are happening. Okay? So how do we think about that? Let me just show you a simple example we actually do in our class. So in our class, we give students this little demo. We give them a social network simulation. And the idea in the social network is you have these blue dots, which are, the dots are the users in the social network. The blue dots represent people who have a slight preference, not huge, a slight preference for essentially news that's kind of more on the left wing. And the red dots are people who have a slight preference for news that's on the right wing. And everyone, shockingly, in the social network is friends. So everyone is friends with each other, so they can potentially share information with anyone else. But there's an algorithm that governs the social network which says, I'm likely to show you particular pieces of information based on what you are likely to click on as I learn from your click-through rates over time. And I have some knobs I can adjust as to how much I want to try to maximize revenue by just showing people stuff that they're likely to click on. So we give them the simulation, we have them run it. Day 0 in the simulation, everyone is equally likely to see any piece of information from everyone else. And everyone's friends, right? It's a happy thing. So then we say, let's turn up the crank a little bit and see what happens over time. So here's day 50, here's day 100, 150, 250, 350, there's day 500. Okay? Social network's broken in half. Everyone lives in their own world of information. And no one came along at the company and said, you know what, I want to create polarization. I want to actually split up people into different groups. They said, what I want to do is I want to maximize click-through rate, because that generates the most revenue. That is a poor proxy for connecting the world, but is the proxy the places like Wall Street care about when they're determining the valuations for company and the revenue generation. When we give this to students, we basically tell them, we give them a very simple revenue model. You can see there's total revenue up there as well. And we say, imagine you work for this company. You need to write a memo to the CTO of the company and explain how you would set the parameters. And depending on how you set parameters in this model, you either get this or you get something that looks much more like this. And that's going to have an impact on revenue. How do you justify it? And you get the whole spectrum. But what we want students to think about is the fact that this exists. It's something you can even measure. And then you need to understand how important it is to actually mitigate that kind of behavior in our society. Okay? So to wrap up on a more hopeful note, you might see all this stuff and you're like, oh my God, like, it's just all downhill from here. Like, you know, the place is on fire. What can we do? The thing I want to leave you with, I'm actually, and my wife will tell you this, I am an eternal optimist, overly optimistic, some perhaps would say it, but I'm an optimist. Technology is not a wave that has to wash over us, right? Sometimes we just feel powerless. We're like, what can I do? I just exist in this ecosystem. But it's not a wave. We sort of get, in some sense, what we are willing to put up with. The first thing you can do is thinking about the effects of technology are something that we can control. Right? We have an ability, you know, at the simplest level, we are all citizens. And interestingly enough, there's kind of a policy window that's opened up in Washington recently where politicians are beginning to actually look at some of these issues more seriously. So California actually, a couple years ago, passed the California Consumer Protection Act, which actually has a bunch of safeguards in there for your privacy. A few other states have done similar things. And there's a move to potentially get federal legislation along these lines. And interestingly enough, the companies actually are in favor of it. Why would companies be in favor of federal legislation for privacy? Any idea? Well, they're still going to be liable, Even playing field. What they don't want is they see this train is moving, and they don't want 50 different policies in every state that they need to comply with. So from their standpoint, they're like, it's already in California, it's already in Illinois, we see it in a few other places. Like, all right, this is going to happen, just give us one, and that'll make it easier to deal with. But it means it opens up the window for something to happen, and that gives us, all of us, the opportunity to say, hey, you know what? Yeah, I know, I'm old school, but you can actually like contact your representatives and say, these are the things I care about. Because a lot of them are trying to make some change, and they don't understand fully what people's value system are, where people stand on these issues, what you actually want protected. But there's other things you can do. There's kind of things at the individual level, right? There's the, well, you can pick what apps you want to use, your privacy settings in those apps, or privacy settings on your web browser. You can have plugins to get rid of your search history. Now every website you go to has a little cookie thing, right? How many people have seen that where you go somewhere and it says, accept our cookies? How many people just click accept the cookies? Yeah, sometimes it's just easier to do that. But you can actually set your preferences. That's thanks to a policy called the General Data Protection Regulation, which actually came out of the European Union and was part of a model for how we got the California Consumer Protection Act in the United States. But all these things I mentioned before are not sufficient, right? Individual solutions don't inoculate you from the bigger picture. What we need is a systematic solution. Now, sometimes the way this is couched, and I hear this phrase a lot actually when I go and try to talk with entrepreneurs about some of this stuff, is the phrase, Europe regulates, the United States innovates. And if you try to regulate, what you're going to do is you're going to kill innovation in the United States. I say, okay, that's interesting. What about the roadway system, right? At the turn of not this past century, but the century before, when cars were getting mass produced, we had a bunch of horrific accidents on the road and people died. So what did we do? Did we just say your only choice is you either drive or you don't drive? You don't like what's happening with cars, just don't drive. No. We created a set of roadways and told people there's a side of the road you drive on. We created lanes. We created speed bumps around schools. We created traffic lights, stop signs. We created a whole system of safety around automobiles where everyone still has the individual autonomy to say, do I want to drive or not? What kind of car do I want? How do I want to participate in the system? But there's a set of rules that make driving safer for everyone. And we still get innovation in automobiles. That's the same sort of idea around technology, is can we get a set of safeguards in place that make it safer for consumers to participate on the information superhighway and make it safer for everyone as a result? And the way we do that is through, among other things, our democratic process. But there are a few other things we do. One is we can actually think about building a code of responsibility into computer science, which is some of the things we're trying to do in what we teach. We're putting more discussion of ethics and modules across the whole computer science curriculum, not just in one class. But the idea behind this is to say, if you consider other professions, if you consider the medical profession and you commit malpractice, you lose your license. You don't get to practice anymore. If you consider the legal profession, and you do something that is malfeasance, you're removed from the bar. You don't get to practice anymore. We don't have anything like that in computer science. You build some system that breaks our democracy, you get a bunch of funding to build the next system to make it worse, right? And so that's one of the things to kind of think about, is trying to build that culture, and there's lots of ways of doing that. But that's one of the things that's actually interesting about being in Silicon Valley, is there's a lot of people, executives, rank and file employees, funders, who actually this resonates with, and are making decisions based on thinking about how do we try to inculcate more of that culture in the Valley. Checking the power of large technology companies. I say this, as you know from the introduction, I spent sort of the better part of a decade working at Google. But if you think about who has power with respect to who gets free speech, right? And this is one of those things we see kind of play out with Twitter right now. And also I hear like Parler is getting acquired by Kanye West. I saw that as a headline. I was just like, I must be dreaming, or like this is like some dystopian state or whatever. Like, I don't know what's going on here. But basically, we have people with lots of money making decisions about who has speech rights. We have a bunch of people with a lot of money making decisions about who has privacy rights. And there's very little recourse there. One of the things we could actually think about is structures that actually provide more of a societal input into those decision making. And that's the last thing, is building a democracy that's capable of governing technology. Now, a lot of people look at that and they're like, oh, Mehran, you're kidding, right? Like, our Congress is gridlocked, people are yelling at each other. That's what it looks like, on social media. There actually are some very interesting things which have bipartisan support, which are moving forward. Some are more contentious than others. But part of the way we actually got to where we are now is we gave up some of the structures that actually gave Congress the information it needed to make these policies. Anyone remember the Office of Technology Licensing? Or that's the Stanford, the Office of Technology Assessment? Like in the 70s and 80s, there was folks there like Ash Carter, who has a PhD in physics and actually later joined the cabinet. That got disbanded in the mid-1990s as part of the contract with America. And the idea was we had a governance structure in place that actually was providing, more or less, depending on how you look at it, nonpartisan guidance to people in Congress to make tech policy. We don't have that anymore. What we have is a lot of lobbying that's helping write tech policy, and what we're trying to get back to is a place where there's actually more of that policy is being written based on individual and societal input coming into that process. But this is ours to own, right? Because when we think about our democratic capability, that kind of puts the onus on us to say we need to be clear about what values we want, how those values get encoded, and how we make it clear to others that these are the things that society should actually value as we move forward in the realm of technology. Thank you.